Okay, how are we doing today? Gonna do a quick little demo on boiling. Has to do, remember boiling, a liquid will boil when table pressure equals atmospheric pressure. So we have our table H that you can find on your reference tables up here. And the normal boiling point is when the atmospheric pressure is at standard pressure. So that 101.3 kPa is 1 atmosphere, 760 millimeters of mercury. All right, so I'm gonna be bouncing the camera around a little bit today, so just give me a second or two in between. So right here we have two containers that currently have water in them that are boiling. All right, so the container on your right has got an Erlenmeyer flask. All right, it's got water in it that's boiling. If I had a thermometer, it would be somewhere in the ballpark of 100 degrees Celsius. We're not quite at 1 atmosphere of pressure, 101.3 kPa here at CNS, but it's just slightly less. So the temperature of this boiling water is probably 99.8 degrees Celsius or something like that. All right, so normally when you boil water, whether it's to make pasta, to do this demonstration, make your SpongeBob macaroni and cheese, whatever it is, you're gonna take the liquid and you're going to raise its temperature, which is ultimately going to raise its vapor pressure until the point when that vapor pressure equals the atmospheric pressure pushing onto it. And when those two equal each other, the liquid will boil. All right, so that's what's going on in the Erlenmeyer flask there. All right, and our round flask, or our Florence flask here on the right, all right, I'm gonna take this flask off the water, or off the hot plate. I'm going to put a stopper on it. All right, we're gonna see that, pretty quickly, the liquid in there does stop boiling. All right, I'm just gonna wait a little bit more pause in there. I'm making sure that the camera kind of shows it pretty well. That's not too bad. We'll zoom in so you can kind of see it. I'll try to keep it in that same way. So there you can see that the water is not boiling right now. Okay, what I'm gonna do here is I'm going to just hold on. I need the glove to hold on to it. I'm gonna take some ice. I get a decent piece of ice, here we go. I'm just going to, quote unquote, put the ice on the edge of the container. All right, looking at this, if you look down at the bottom of the flask, you can see that the water is now rapidly boiling. All right, so I'm technically boiling water with ice. Kind of a cool thing. All right, and what we're doing in this case, instead of heating up the liquid to raise its vapor pressure, we're actually cooling down the atmosphere in here, and we're lowering the atmospheric pressure in here, and we're lowering it down to a point where it's actually going to boil the liquid that's in here. All right, and this is just water, all right, but it's now boiling at a temperature that would be slightly less than 100 degrees Celsius. Kind of a cool thing to see the water boil in that environment, all right? And you can do it, I turn on the side so I can get more of it here, but I can do it back here. Should be able to do it back here. And we can see that we can get that water to boil in there. Kind of a cool thing to see, okay? All right, I'm gonna boil water one more way today. All right, so we're gonna move over to here, all right? This is our vacuum pump, okay? And I'm just gonna show you what it does and the sound that it's going to make more importantly. All right, so this is a vacuum pump, and this actually sucks in air. All right, right now I have my finger on the end of the tube, and it's kind of quiets it down as it gets to its maximum capacity. And then what I'm going to use here is I'm going to take this flask right here. This is another Erlenmeyer flask. All right, if you look at it, it's got 2 thermometers in it. I'm trying to angle it so you can see it. All right, I'm going to pan out just a little bit. All right, it's got 2 thermometers in it. One thermometer is measuring the water temperature. The other thermometer is measuring the air temperature. And you can, I'm going to put it up here. I don't know if you're really going to be able to see it with the glare of the lights. All right, but the temperature of the water right now is about 21 degrees Celsius. It's in that range, somewhere really close to that. And then the air temperature is in that same range as well. So these are room temperature water, everything like this. What I'm going to do is I'm going to attach the vacuum pump to it. If I can. It's tough sometimes with it running. All right, there we go. We got it. All right, and I'm just going to let it go for a couple seconds here, 30 seconds, 40 seconds. All right, and we're gonna see here, so you can see that it's getting to its max capacity because the pump starts to quiet down. All right, but looking at this, we can see something's happening to the water in there. All right, the temperature hasn't changed. I don't know if you can see that on there. All right, but the temperature has not changed. But now notice what's happening to the water down here. You can see little bubbles forming. So what's happening in here with this vacuum pump is we've actually sucked out enough air, all right, to lower the pressure low enough so that its atmospheric pressure in here reaches the water's vapor pressure at this lower temperature, this 21 degrees temperature. All right, so technically this water is boiling at room temperature. All right, wouldn't work so well to cook pasta or your SpongeBob macaroni and cheese, but it does work to meet the requirement for a liquid to boil. Okay, so that's that one. That's another cool one. I'm gonna do one more while we're at it. So in here we have another Erlenmeyer flask. Inside the Erlenmeyer flask, I don't know if you can see that there's a balloon in there. All right, this is a Boyle's Law thing. I'm gonna have you guys kind of predict what's going to happen. So I'm going to attach the hose to it, and we're gonna see what happens to the balloon. All right, you can see clearly that the balloon is expanding in size. And the reason why the balloon's expanding in size is because we're decreasing the pressure outside the balloon, and the balloon's increased pressure inside is allowing it to expand. And it gets to a point where it can't expand anymore because we cannot decrease the atmosphere in there any more than this with this pump. So you get there. When we open it to subject it to atmospheric pressure again, I'm going to first turn this off. All right, and then so you can hear it. You can hear the air rush in. It's rushing in through this little sidearm, all right, and it actually pushes the balloon back to its original size. Okay, so those are some cool demos or some quick demos with boiling and Boyle's Law.